Hi there. Good day. Welcome to our session. So, for today, we are going to implement the different algorithm techniques that we have discussed. Um, so, let's start and go directly with uh, our program. So, here we are going to create a, class that is to implement the first algorithm technique, which is bubble sort, which is the simplest one. So let's name it like bubble sort. Okay, and then click on finish. So now that we have already here so a class, and then we have already the main. So this time we are going to create an array. Let's say we have let's just initialize the array to the array values by, let's say, 23, 65, and let's say we have 10. Let's make it far sorted array. And then we have 5, and then we have, let's say, uh, 37. Okay, so let's have 5 elements for our array today. Okay, so this time we are going to create a third party variable. It's a holder variable in which it's going to be assigned with the value. So we get to assign a value of our, because this is the value will be our this is the variable that we'll be using for like once we go through with the swapping, so that we will not lose the data or the elements of the array. Okay, so to start, let's initialize this to 0. Okay, so this time let's create a two uh, nested loops, the outer loops and the inner loops, which is that is the behavior of making as our implementing a sorting. So let's have this as our outer loop, as to represent we have x. So we have x is equal to 0, x is less than to the length of the array, and then we have here x plus plus. Okay, and then let's have here end of let's say outer loop, and let's also put this one here, end of main, and then we will also include here end of class, right? So that's it. Now this time we are going to create another loop here. So let's say we have int x or y to represent outer inner loop rather. So we have y is equal to 0, and then y is less than to the array length. So we'll have to put -1 right here. Later I'm gonna explain why we do that. Okay. So and then we have y plus plus. Okay, so again in bubble sort, as a review, we have to compare the element. Okay, and then if they are not in order, they are going to be swapped. So like for an instance, you compare 23 to 65. Let's say we are going to arrive, or and our goal is to sort them in ascending order. So 23 will be compared to 65. If 23 is, let's say, greater than 65, so that's false, therefore they are in the right position. So 65 and 10 will be now compared. So is 65 greater than 10? So they are not in the right position, so therefore we have to swap, and then we'll be using hold to get the value of 10, and then swap. Before we swap 65 and 10, and then swap, and then the 65 will be compared to 5, and then swap. So because 65 is greater than 5 and 65 is greater than 37, so we have to swap 65 and 37, and you you and then you do that for the rest of the other elements of an array, again and again, until the inner loop is done already comparing, and then it knows when it is done, when the outer loop is actually finished, or if it ends. Okay, so here we are going to do that comparison or comparing mechanism in which we get to have an if condition. So let's put this one end of inner loop, and then we have here end of if. Okay, so that we will not we don't we are not going to be confused like especially because of there are actually lots of open and close curly braces here. So here we are going to compare the our value or our array. Let's say the first value that we get to compare is the first indexed, and then after that we get to compare them into if it's greater than to the next element of the array. Let's say we have y, and then we'll have y plus 1. So the very reason why we have here minus 1, it's because as you can see, if this is y plus 1, it's going to be this one is like if our y is 0, and therefore this one is 1, so it gets to compare the first index and the first index, which is 0, and then the second index, which is 1. So that's basically y plus 1 is 1, this one. And then when this iterates or loop again or loops again, this would have y plus 1, so it becomes 2. And then 2 plus 1 3, 3 plus 1 4. Now when it reaches to 4, this will become since the length of our array is like 5. Therefore, when up to and the index is like 1 to 4 only. And remember, when we are in here, let's say for an instance, we are in this, what they call this one, we are in this fourth index in the rather what they call this one, right, this one now we are in the fourth index. So 4 plus 1 is 5, and there's no such thing as what they call this one, there's no such thing as fifth index, I mean index 5 in our array. So in that sense, we the error will occur, which is array index out of bounds. And yeah, no, so this time we after whenever there is true, or whenever the they are not in the right position, so we'll have to compare them. I mean, we'll have to swap them. Okay, but before we swap, we'll have to get the value first. Okay, get the value first. So let's say we have we'll get this value once it is true. Okay, so let's say we have here array, yeah, array y plus 1. Okay, and then after that we are going to we are now safe to replace this array by the next element, which is, let's say, y plus 1. So this time what we are going to do is we'll have here array y, so meaning to say we are now swapping the value of the let's say this one. So we are now going to swap 23 and 65. And then so we are it's okay to swap them because we already held the value here in the whole variable of y plus 1. So it's okay to replace it with the value or the next value. Okay, so after that we now use, or we can now replace the value of y by the value which is we store in the hold. Okay, which is basically the value that we hold temporarily. Okay, so now we can actually read the our program. I mean, let's say we are going to run rather, and then later on we're going uh, to trace the program as to why yeah, we are going to trace the program so that we are able to compare our especially because we'll have to see the swapping of elements. Okay, let's run the program. But yeah, we don't have any. Let's call the update of the first. Now let's call the update of the value, let's say we are going to use, we can use x, but let's have I. So we have is I is equal to 0. I is less than the array, the length of the array, and then we have I plus. Okay, so right here we are going to uh, let's have here a all string variable which concatenates all the elements of the array. So that uh, every time the loops iterates, and every time this will execute, it will just concatenate the value. So let's say we have all plus equals array I. Okay, and then we'll have a separator. Let's say our separator is uh, space, or let's, to be safe, let's have backslash t. Okay, and then we are now going to display them in J option panes. Show message catalog, and then we have all. Okay, so again, by the way, J option pane is automatically imported. It's under javax.swing, and I already discussed that one before in during our session, our previous session rather. So right here we are able to display the sorted elements. So this is the sorted elements 5, 10, 23, 37, 65. We can put something like actually we can put something like unsorted, which are this one, and then we can have here like sorted. So we can do that by, let's say, we'll have to, okay, and then you have here the you have here the unsorted. You can have here, let's say, let's have another one, and let's say unsorted equals, and then we have sorted equals, and then we will use all as the we will combine sorted and unsorted. So let's say we have unsorted, okay, and then we have here sorted. So right here we can actually use all. So all is equal to unsorted backslash t. We have unsorted. Sorry. Okay, and then let's have backslash n to move to the next line. So we have sorted backslash t, and then we have sort, and then let's put all here. Okay, so this time we run the program, and then we have here unsorted and sorted. By the way, to have a better representation of our program, we can actually put a it's a JText area here, because the backslash t will not actually work successfully if we don't put JText area. I mean, we don't include JText area in our J option page. So it would be better if we include this one. So it's like a notepad. It's like a text. Yeah, it's a note. It's like a notepad in Windows, and this one will actually read the backslash t now. So it's still under javax that swing component, and since they are of the same uh, library, we can actually make them like that asterisk. So meaning we are now going to use all the classes inside of this library. Okay, so this time we are going to put all inside of that JText area. So right here, after that, we now display the unsorted, which are 23, 65, 10, 5, and 37, and then the sorted value, which is 5, 10, 23, 37, and 65. Now again, let's have here the how is it done through this loop. Okay, so first is let's focus on this part, because this one are just for displaying purposes only. So this let's focus on this one. So we have our original array is 36, 65, 10, 5, and 37. Okay, and then I'll have here a comment section, which is I'm going to have here the loop times, or let's say we have the loop times one, or say we have loop one. This is for, yeah, or let's say loop one. Okay, so this time we are going to use these elements. So right here we get to compare. I mean, first is we have 23, 65, 10, and then we have 37. I know we have 5 here. Okay, so again, we have 23, 65, 10, 5, and 37. Now here in when x is 0, so when x is 0, let's say loop 1, so when x is 0, okay, so and then so is 0 less than the element the length of the array, which is 5. So the length of the array is actually 5. So make again, take note that the length of our array is 5. So is 0 less than 5, it's true. Therefore yeah, so we'll have here basically, let's say x is 0. Let's have, let's have here length x is less than to the length, let's say length of array. So we have here, so our x, when our x is 0, our length we have here 0 less than 5. So is 0 less than 5, that's true. Therefore when x is 0, 0 is less than 5, that's true. So it will go here in our inner loop. Inside of our inner loop, so you have here y is 0. So is y is less than the length, which is 5. So 5 minus 1 is 4. So is y less than 4? That's true. Therefore, if since it's true, it is going to read this block here. So it's the comparing process of our array elements. So this time we have here a let's say array y, which is 23. So we have 23, and then what happened with the sound, it's like someone is working uh, there. So anyway, we have 23. 23 is going to be compared to the next element, which is y plus 1. So y plus 1 is our value, the value of our y is now 0. Yeah, so it's now 0. So y plus 1 is 1, therefore it's 65. So we have here 65. Is 23 greater than 65? That's true. That's false. So therefore, there is no swapping happens. So in this case, this will not be read. No, this will not be executed. So it goes back to our inner loop. So our y now would be y now would be 1. So this is like y is uh, 0 again. Now when our y is 1, okay, so is 1 less than 4? That's still true. Okay, so this time it has to compare the next element, which is 65, this one. So 65 and 10. Okay, so it's 65 and is greater than 10. So if it's true, okay, so if it's true, then it has to swap the element. So since true, 65 and 10 will be swapped, but before we swap them, we'll have to get 10 first. So 10 will be assigned to hold. So in this case, the hold will have now the value of 10. Okay, and then the array 1. Okay, so the array 2 rather, because our y is 1, and that is 1 plus 1 is 2. Yeah, 1 plus 1 is 2. So array 2 is now would now have um, 65. Okay. All right. So here our array 1 would have now 10 because the value of hold is 10. So the swapping process is finished, and then we don't lose any value from our elements or array elements. So now in it it is going to continue again, go back to so our the since there is now the changes, now there is now changes in the elements of our array, so we'll have to swap 10 and 65. So actually, actually for 65 and 5 and even 65 and 37, that's gonna be the same with what we have right here. But let's go through the process. So let's say we have y becomes 2. So because it will increment by 1, so 2 is less than the length r dot length, which is minus 1, which is 5 minus 1 is it becomes 4. And then since 2 less than 4 is true, so this time we'll have to compare again 65 to 5. So 6 is 65 greater than 5, that's true, therefore we'll have to swap 5 and 65. But before we swap, we'll have to store first 5 to hold temporarily, and then swap now 65 and 5. So this time we are going to change this one. So because we are now in the array 3, so that's array 2 plus 1 3, so it stores 65, and then the array 2 would have the value temporary. I would have now the final value, which is 5. So this time the changes of our array becomes uh, 65 and 5 will be swapped. So we have here 65, 5 and 65 will be swapped. Again, the same thing in 37 and 65 and 37. So when our array is 3, all right? So 3 less than the length of the array, which is 5 minus 1, 4. Therefore, true. Okay. So 65, and this time 65 and 37 will be compared. When it is compared, 65 is greater than 37, that's still true. Therefore, 37 will be assigned to hold temporarily. And then after that, we are going, this one would be, since 3 plus 1, it becomes 4 because this is our formula right here. And then we are going to assign 4. We are now going to this one, 65, assign 65 to array 4. And then for array 3, okay, because we are now in array 3y, so we'll have to mm, store now the 37 30, which is from the hold value. So we are now going to store the 37 on the array 3. So this time 37 and 65 will be swapped. So it goes back to the inner loop. This time, our y becomes 4. So 4 is less than to the array length minus 1, which is the array length minus 1 is 5, minus 1 is 4. So is 4 less than 4? So 4 is less than 4 is actually false. Therefore, okay, therefore what will happen? So it will end the inner loop. So once the inner loop is going to end, this time our outer loop will be uh, go back to work again. So this time the final value of our array is 23, 10, 5, 37, and 65. So when our let's have here, when our x is 0, this is our array. So this is now the final value for our array in the first loop, no? First loop of our inner loop. Okay. Next is we are going to do the same process. Okay, since you already know, yeah, no. So using this updated value of an array, we get to compare again. So it's like this. We get to, so you go back again to like your y becomes again 0, and then so it is going to compare 23 and 10, because we have here y is 0, which is 23, and then array y plus 1 is 10, which is actually index 1. So we get to compare the 23 and 10. So because 0, yeah, 0, this one is always true until actually we reach to this value. Okay, I mean in this, because this is the index 4. Yeah, this is index 3 plus 1. This will become, this will make the loop false. Okay, anyway, so we have here y, uh when our y is 0, again it gets to compare 23 and 10. So 23 and 10, is 23 greater than 10? So 23 is greater than 10. That's true. Therefore, the 10 will be assigned to hold, and then 23, okay, this is like 1, so 23 will be swapped, or will have now a swapping, which is array 1 will have now 23, and then our array 0 will have actually the value, which is 10. So this time the changes of our array is like, it's going to be like 10, and we have 23. Okay, now next is when our y becomes 1, okay, because the I would increment by 1. So we have here 23 and 5. This time we have 23 and 5. So 23 will be compared to 5. So is 23 greater than 5? That's actually true. So therefore, we'll have to uh, take 5 temporarily, and then let's swap the this would now become array 2, because 1 plus 1, that is this one, 1 plus 1 is 2. So we have here yeah, it's 23, and then this will be array 1, and this is going to get that whole value, which is 5. So this time the array, so we have array, this one, we have 5, and then 23 is going to be swapped. All right. So after that, the our y becomes 2, and then 23 will be compared to 37. Is 23 greater than 37? That's actually false. And so once it's false, it goes back again to this one, because it will not execute this execution right here. And then we'll have here when our y becomes 3, we'll have now 37. So 37 is going to be compared to 65. So this time kani. So we have 37 and 65. It's still false. Therefore, it is not going to execute this one. So now, when our y is 4, it's going to be right here. So y, which is 4, less than the length minus 1. So again, length minus 1, to make it clear, length minus 1 is 5 minus 1. So which is the length of our array is actually 5 minus 1. It becomes 4. So 4 4 less than 4, it's false. Therefore, it stops the loop. So the inner loop rather. So our array now is the updated array value now would have here when our x is 1, we have an updated value for our elements of our array 10, 5, 23, and 37 and 65. Okay, that's the second loop for our outer loop. Okay, let's now proceed. So since this is now the final, this is now the updated value of our array, we are now then going to compare yeah, so our x will now become 1, okay, and then 1 is less than the length, which is 5. That's true. Therefore, what will happen, it is going to execute again this inner loop. So this time we'll have to use the same process. So going back again to 0, and then it compares again to 0 plus 1, which is actually yields to 1. So it's going to compare 10 and 5. So this time is 10 greater than 5. That's actually true. Therefore, there's swapping happens. There is actually swapping that will happen. So this time, 5 will be temporary hold, is going to be held temporarily by hold variable. And then we have here, this one is, yeah, this one is like array 1. So this is, so since 10 and 5 are compared, so this will become 10, and this is the array 0 will now become, sorry, the array 0 will, but will actually hold the value that is being held by the hold variable, which is 5. So now we have a swapping happens. So we have 5 and 10 will be changed or interchanged or swapped. So we have 5, 10, 23, and 37, and 65. So this time will y becomes 1. So it's going to be accessing the index 1 of our array. Yeah, so now, so we have 1 here. I mean 10 here. So 10 greater than 23, that's actually false. So it means it is not going to read this one. Okay. When our y becomes 2, so this time it's 23 to 37. So ayan, 23 and 37, and then 37 and then 65. That's actually false. And then we have y, when our y becomes 3, next is 37 and 65, that's still false. And then when our y becomes 4, 4 is less than 4, it's actually false. Then therefore, this is the last, no swapping so far. So this is the updated value of our loop. So this time when our x is equal to 2, we have here that one. We have these values right here. So far it's actually sorted, right? It's actually sorted, and it would mean that if no matter how many times this would execute, actually the loop will execute, it's still going to be always arrive with the same values of elements, because it's this with the comparing process will always be false. So, and the bubble sort does not have that mechanism to know if our array is already sorted, because it is going to only follow what is instructed to them. No, it's going to only follow what is instructed to by us. No, okay. So that's how bubble sort really. So therefore, we'll be using this one. We can actually try it out. So we have here, when x becomes 3, so it's going to be again going back to 0, and then compare 5 to 10. So that's like 5 is greater than 10, and then 10 is great. It's 20. So that's false. Balik na po siya. And then we have 10, 10, and 23. So that's false. And then 37 and 23 and 37 and 37 and 65. That's still false. So the updated value for our loop when our x is actually 3, it's going to be uh, it's going to be 5, 10, the same. No? Okay. So again, when we, even though we do the same process, it's still going to be false. Again, it's useless to do that. But then again, our program will keep on doing the same process and again, even though if it's always arrive with false or the same elements, and it's always going to execute this process right here, but actually not this one, not include in it will not include this one. Okay, when our y becomes 4, you will have another or the same value. So this time our x would now become 5. So based on the length of our array right here is 5. So is 5 less than 5? It's actually false. So therefore, this is the comparison process of our bubble sort. So actually in the third loop, it's which is when x is 2, it's already sorted. Okay, we can actually trace this one out. and even display in our program. Okay, so yeah, so to do that, we can actually include it right here. So yeah, we have here, let's say, and let's have another one. Let's say CTR or counter. We have 0, and then CTR is less than, let's say, we have um, R length, and then we have uh, CTR plus plus. So this time we are going to use, so let's remove this sorted and unsorted elements thing. So we're gonna be uh, removing all those and then have here all, okay? Instead, sorry, I'm sorry. So we have here, so let's have here. Anyway, let's just make this one as, okay, so by the way, yeah. So we have here all plus equals the our array, so the updated array. After everything, after actually after the this one no process everything, when this ends, this will be executed. This is still inner loop. However, this is going to be only going to read the updated value of our array. All right, so we have here CTR, and then it's here backslash t, and then so we should not erase our anyway. So let's have here uh, I just forgot. I erased the, you know. Anyway, so let's move on. And then we have here, yeah, so it's already like that. And then we'll have to concatenate, and then let's have backslash, and so that the updated value, and then here's the updated value of the element of the array, and then move to the next line again, and move to the next line again. Every time we'll have an updated value, so that we get to see the the representation of each loop. Okay, so after that, we can actually remove this one out. Yeah, so because we already have the all there. Yeah, so let's try. Yeah, okay. So this is going to be reading the for the first loop, second loop, third loop for until it is going to be sorted. So let's run the program and let's have here. Yeah, this is the uh, update. This is the, yeah, after the first loop. This is our like unsorted array 23, 65, 10, 5, 3, 37, and we get to compare them in our loop. And then first loop would have 23, 10, 5, 5, 37, and 65, and then 10, 5, 23, 37, and 65. As you can see, uh, as what we have actually written earlier, which is I actually erased by mistake. I'm sorry for that, but we were able to actually come up with the same output of elements. I mean, in based on the swapping when we get to trace earlier. So as I have said earlier, on the third loop, it's already sorted, and for the next succeeding loop, it's always going to follow the elements because again, it's already sorted. All right, so that's actually bubble sort. We can actually put a a like this is not accurate, by the way, because this will also based on your the speed of your computer as well as, but this would vary because depends on how much processing time. We can actually include that one in our program. So let's say for an instance, system that let's say we have nano. So let's not do current milliseconds because it's fast. So we have nano time, so nanoseconds, and then we are going to end it right here. So we have end nano time, and then we are going to have let's say, yeah, so let's make use of this all to represent the array, yeah, class, and then we'll get to add or concatenate. We have um, what we call this one, the time. So, and let's say we have, what is this? Time units. Time units. So we have, let's say, and minus start. Okay. So time units for bubble sort we get to see. So let's try. So yeah, we have 259,164 nanoseconds. Convert it into second. So do it for yourself. Anyway, and that is not going to be always, that it's not fixed. It depends on the processing. Yeah, as I've said before, it depends on the processing speed. It depends on the speed of your computer. It depends on the speed of, yeah, it actually depends on the speed of your computer, as well as because we have a lot of applications that are actually running rather. So this time you can actually we can actually get to compare this to later on to other sorting algorithm. So let's say we have a, it's not going to be always like this all the time. So but then again, what one thing for sure here is that it affects the time units here are units here are is actually going to be based on the processing right here. Okay, so the more your array is far sorted and you will have a lot of elements, it's going to be so like let's say 45, 67, 100, 89, and something like that. It's going to increase the not time units now. It's going to increase the time units as we increase our elements. So I guess that's it for our the bubble sort topic. And thank you guys for listening. Have a great day. See you guys around.